All right, everybody, we got an important challenger here. I'm going to look at my Lie table. Of course, this is exponential, and this is trig. So du is up. Excuse me, u is up. So I got sine x here. And so du would be cosine x dx. All right, dv is down, e to the negative x dx. So v would have to be negative e to the negative x. All right, so you're going to see something pretty crazy happen here, but let's just go with it. So technically speaking, this would be equal to uv, which is negative sine x e to the negative x minus the integral of v du. So the negative on the negative e to the x I'm going to pull out in front. So that'll be e to the negative x cosine of x dx. What the heck? So you might be looking at this thinking, how in the world am I supposed to do this? Right? Because what's going to happen here? The same thing. It's going to reciprocate, right? Because e to the x, the derivative or the integral, is always something involving e to the x, so it's never going to simplify. Cosine of x is just going to oscillate. It's going to go back and forth, so the derivative of cosine is negative sine. Derivative of negative sine coming back to cosine. So something pretty cool happens here. I'm going to write up the original, and then I'm going to write in what we got. Okay, and you're going to see something really cool happen. I'm going to do integration by parts again. Okay, so u dv, du, and v. Alright, so what would u be here? Well, u would have to be cosine x. So du would be negative sine x dx. dv would then be e to the negative x dx yet again. Therefore, I'd get the same for v as I did before. Alright, so what is this really doing? Well, what it's doing is now I'm going to be doing a substitution, okay, where this is going to be equal to uv. Okay, so uv is negative e to the x, okay, cosine x, minus the integral of v du. Okay, minus, now the negative here on the v, I'm just going to bring out e to the negative x sine x dx. Alright, so you're like, what? Should I do it again? No, you only have to do it twice, ever. Here's why. Check this out. You notice anything cool there? Well, what you can do is you can add, whoops, I got to pay attention here. I had two negatives, which would make this a negative. Okay, so that is not a positive there. That should have been a negative. I can't get rid of it either. Okay, so just a big old negative sign. Okay, that's minus. So if I add integral of e to the negative x sine x to both sides, add it, e to the negative x sine x dx, guess what? I get two of those. And they are gone from the right side. That equals negative sine x e to the negative x minus cosine x e to the negative x. Written in either order, doesn't matter. And so to find the integral of e to the negative x sine x dx, I just multiply this side by 1/2. And actually, I'm going to make this simple by pulling out a negative. And leave it just like that. Don't forget, plus c. All right, you guys, you only ever have to do that twice. If you see something trig related and with e to the x and you're supposed to do integration by parts, that's it. You're done, right? Do integration by parts twice, bring that common integral over, divide by its coefficient, and you're done. Very important challenger. It's come up on numerous HL exams in the last few